when you really tired and you just gotta press through because it look like it's gonna rain real good outside. Woo. I'm pushing through, Jesus. No, man. Bro, I feel like y'all got the most talented teacher ever. Cause like, I can rap, I can sing, I can do math, like, I can dance. Like, what else could you ask for? I'm funny. What else can you ask for out of a teacher? Get on back in here. Come here, go. Okay, Unit 3 test, man. Listen, this is the easiest test of all the tests. Do not let this test get you out of body. Tickets to the zoo cost $12 for adults and $8 for children. Miss Perkins' class spent $240 on their tickets. An equation representing the cost of the trip for Miss Perkins' class is 20 equals 12x plus 8y. Here's the graph of the equation. That means this graph is important. So, can y'all see? Hold on. Select all the statements that could be true. So that means I'm using this graph to see if these statements are true. So if no adult chaperones were needed, 30 children went to the zoo. Now I'm gonna look at this and I'm gonna see what axis is what. My x-axis is talking about adults. My y-axis is talking about children. So anytime I'm talking about adults, I need to look at the x-axis. Anytime I'm talking about children, I look at the y-axis. If no adult chaperones were needed, no adult chaperones is what number? 0. So when I have 0 for adults, 30 children were needed, okay? So at 0, this is 0 for adults. When I go up to see where my line is at 30. So that would be one of my answers. Lord, and my watch finna die. Okay, man, like, be so for real. If 10 children were to go to the zoo, then 15 adults were able to go. So I need my line to be at 15 for adults and 10 for children, okay? So when I go to 15 for adults, which is right here up in the middle, where's my line? Right here. And that's 7. Okay. So that's not right. But let's check and make sure though. If 10 children were to go to the zoo, so let me look at it another way. If 10 children go to the zoo, that's right here. 15 adults were able to go. My line crossing right here. So that's not true. That's not one of your answers. Okay? If I go to the next one. If 28 people went on the trip, 24 were children. This is a trip. This is most definitely a trip. Because 28 people is not saying whether it's adults or children. That's putting everybody together. So that means I need a 28 total if 24 were children. So let me see how many adults were going if I got 24 children. So when I go to 24 for children, I got 4 adults going. 24 plus 4 is 28. So when there are 24 children going, 4 adults going, and that makes 28 in total. So that's definitely one of them, okay? Don't overthink this, it's just that easy. You're using the graph to answer. If 8 adults went on the trip, then 18 total people went. So let me see how many children went when 8 adults go. So 8 adults, when 8 adults go, I got 18 children. Now hold on, because you said 18 total people went. When 8 adults go, 18 children go. So that's 18 children, not 18 total people. So this is not it, okay? If 16 adults went to the zoo, then 6 children went. So let me go to my graph. I need to go to 16 adults, and when I go to 16, my line needs to be at 6. Where's my line? So when I go to 16, my line meets me at 6. So that is true. Okay, ACE. This is very important. If on the test it tells you to write the systems of equations and describe each variable, bro, you have to describe the variable. I have to take points off if you don't describe the variable. You gotta describe. So as the school sign language interpreter, Karan gets paid $35.50 for every parent-teacher conference that he attends, and then he also gets paid $42 per school-related assembly. Per tells me to do what? Multiply. Every tells me to do what? Multiply. Okay? If Karan earns $991 in total for 27 paid events, in total, how many parent-teacher conferences and how many school-related assemblies did he attend? So I'm going to write my systems of equations. Now, we learned the trick today in class. If you get confused on like what information goes with what, boom, boom, you need to ask yourself what we're talking about first. So we're going to make a chart. Okay? So I see dollar signs. Dollar signs mean money, so I know we talking about money on one of them. Then what else we talking about? The amount. Okay? And then I'm going to separate my information just to make it easier. So I know it's $35.50 for the parent-teacher conference, and I'm going to put that on my money side. And then I know that it's $42 for each assembly. And then I know he made $991 in total. Alright, bam, that's part of it. And then I know he did 27 paid events. Now 27 does not have a dollar sign, meaning 27 is talking about my amount. And he did 27 events in total. Now that's important, in total. Okay? This makes it easier to make my equation because now my information is separated. Alright, so let's make our money equation. If it's $35.50 each parent-teacher conference, each tells me to multiply. So I'm going to have $35.50 X. Let's say X is my parent-teacher conference. And then I'm going to add that together, and it's $42 each assembly. 42 Y. And my $991 total. Okay, that's it. That's my money equation. Now I need my amount equation. This one was tripping us up because it's not a lot of information over here. It's not. Because all we're talking about is the amount of events. The amount of parent-teacher conferences plus the amount of assemblies equal 27. We're not talking about how much each costs. We're talking about how many we do. Now, if you look at this, it's $35.50 each conference. X is the number of conferences. So X plus Y equals 27. And that's my system of equations. So now that I have my system of equations, I have to describe because that's another piece. So X is the number of conferences because X is beside the $35.50 and the $35.50 is for every conference. Number of conferences and Y is the number of assemblies. You will lose a lot of points just for not doing this piece right there. You have to explain what your variables are, okay? Now I'm done with that piece. And now I have to solve. We already, if you haven't seen the video on systems of equations, go watch that video. That's how you complete that problem. You cannot complete this problem without, number one, writing the systems of equations. You cannot complete the problem without describing your variables. And you can also not complete the problem without solving for X and Y. Okay? And remember, if you're watching this video and you don't understand something, you need to be hitting my phone. This charge is $15 for an adult haircut and $9 for a child haircut. We did this during class. A hairstylist wants to earn at least $360 and cut a maximum of 30 haircuts this week. List 2 points. Because you don't have to list the 2 points. You're literally selecting out of this list. So how do you do that? Remember, if you want a solution to a system of equations, I'm only going to pay attention to the points that are in this area. Because this is where both my lines cross. If it's not in this little bitty triangle right here, it's not a solution to both of them, okay? You should have your study guide. So look at your study guide. First option is 10, 15. So I'm gonna go to 10 and go to 15. Would that be a solution to both of them? Not just one, both of them. No, it would not. So A is not an option. If I go to 25, let's say 25, 0. So 25, 0 would be right here. That is a solution because it falls in my little triangle, okay? So 25, 0 is a solution. 0, 30. So if I go 0, 30, no ma'am, no ham, no turkey. If I go 5, 30, 5, 30, what you think? 15, 20, 15 up to 20, no ma'am, no ham, no turkey. And then 25 and 2. So 25 and 2 would probably be somewhere right here. Yes. So your only options that were correct was 25, 0 and 25, 2. Next problem. A student has started a lawn care business. He charges $15 per hour. You must not know about me. $15 per hour to mow lawns and $20 per hour for gardening. So we're talking about 2 things. Because he's still in school, he's only allowed to work for a maximum of 20 hours per week. His goal is to make at least $300 per week. Very important words, at least and maximum. So let's make our system of inequalities. If you see system of inequalities, that means you should not have an equal sign. No equal signs. You can only use greater than, less than, greater than or equal to, less than or equal to. You should not have an equal sign if it says create a system of inequalities. Split our information, because one we talking about money, another one we talking about the hours, because the maximum hours is 20 hours per week. Anything revolving money, mowing lawns is $15, and $20 per garden. At least $300 a week. Let's do hours. The only thing I know about hours is max is 20. Let's do the money one because we good at the money ones. So it's $15 per hour of mowing lawns. 15 per tells me to multiply 15x. Put them together. $20 per hour of gardening. So 20y. And then I want at least $300 per week. So if I told you go out to the store and you should be bringing me back at least $20 and change, that means you can bring me $20, but you better not bring me $19.95 because I said at least $20. So greater than or equal to $300. Okay? Then my other one, maximum of 20 hours. So X and Y is already talking about the hours we mow lawns, the hours we garden. It's $15 per hour of mowing lawns, $20 per hour of gardening. So I know my X and Y is already representing hours. So X plus Y, and then I want a maximum of 20 hours per week. And maximum means he can't go above 20 hours a week. So less than or equal to 20. All right? There's another piece. It says define the variables. I cannot stress this enough. Do not forget to define those variables. If it says define the variables, that's points. You're missing points for not doing something simple. X is the number of hours. And do you have to use X and Y? No, I just think X and Y is easier when it's time to transfer it to Desmos. But you don't have to use X and Y. And Y is the number of hours. Let me just say it one more time because I'm nervous. I'm nervous a little bit. You have to explain what the variables are. You have to. You have to. I don't care if you don't even see it say define the variables. Just go ahead and get in your mind, I gotta explain what my variables mean. Now, what it's saying is, it's only showing me one of them. I gotta find the other one. How do I know which one is which, Miss Davis? I would solve one and see what happened. Because we good at solving it as long as it's y equals mx plus b. But we know how to graph that. So let's solve one and see which one it is. This one the easiest one to solve. So y is less than or equal to 20 minus x. I know I'm gonna have a negative slope. I know my y-intercept is 20. Now if you look at this line, this y-intercept is 15. This line is supposed to have a y-intercept of 20. So I know that this is the one already on the graph. And then guess what you gotta do from here? Graph it, my slope. If it ain't no number, it's an imaginary what? 1. Exactly. So my slope is -1. My y-intercept is 20. Can y'all see how dark it's getting in here? It's getting so dark. Okay, so I'm gonna put my first point at -20, and then I'm just gonna go down 1, run 1, down 1, run 1. Let me show you how you would do it on the test. So that your y-intercept is 20, x-intercept 20, connect. That's what you're gonna have to do on the test. All right, show all the points that represent the number of hours. So for the next problem, it says select all the points, but this is how it's gonna look on the test. So it's gonna show you something like this, and then it's gonna ask you which region of the regions on the graph show the points that represent all the numbers, the hours, all the points. How about I just read it instead of trying to paraphrase it? Like, come on now. Which region or regions of the graph below show all the points that represent the number of hours the student can work at each job and meet his goal? So it's really asking you to guess what's shaded in without knowing what's shaded in. However, because I'm such like a nice person, I'm gonna show you. So I know that this black line represents this top equation, right? And that says greater than. So I know that I'm gonna shade above this black line. Now my pink line says less than or equal to, so I'm going to shade below the pink line. So essentially the problem is asking you which one of these regions represent both of them. Where do they both cross? B, because that's where they both cross. I got black and pink in that little triangle right here. They both cross at B. So B would be the answer for the next problem, okay? So it's asking you, a square is a quadrilateral with 4 equal sides and 4 90-degree angles. Is the quadrilateral a square? So I really want to see the length of these sides. Now I know we didn't do this very much, but you're going to need Pythagorean theorem. How do you find the length? Now, am I going to go through and find the whole thing? No. Just listen. This is how you find the length. So I'm going to make my right triangle. And remember, a right triangle is a triangle that has a 90-degree angle. So I'm going to make a right triangle right here with AB. And then I'm going to measure the sides. 1, 2, 3. 1, 2, 3, 4. Bam. I know that. Now I know that Pythagorean theorem is a squared plus b squared equals c squared. And AB is the legs and C is the hypotenuse. I have the legs right here, so I'm just going to plug that in. 3 squared plus 4 squared, and I'm going to see what c squared is. 3 squared plus 4 squared is 25. However, when I put these two together, I get c squared. I just want c, not c squared. 25 is c squared, not c. So in order to get c, I have to take the square root of 25. And the square root of 25 is 5. Okay? Let's go over how to do that. To get square root, you have to hit second, and where you do x squared, hit that and you'll get this. And the square root of 25 is 5. Alright? The length of this side right here, AB, is 5. Alright, let's find the length of the other one. Four equal sides? Yes, it does. And so, how do I figure out if it's a 90-degree angle or not? So I'm going to go back right here. And then I want to see, I know that 90-degree angles come from perpendicular lines. So I want to check the slopes of the lines to see if they're perpendicular. How do you do that? I know I said don't use rise over run. And I don't want you to use rise over run if you feel like you're not good at rise over run. However, is it easier for this problem? Yeah, because by the time you get done finishing what the length of the sides and stuff are, oh baby, you tired, okay? So 1, 2, 3, 1, 2, 3, 4. I rose 3, I ran 4. And it's easier to do rise over run because you already did this. You already did this. So my slope of AD is 3/4. Let's find the slope of BC. I'm running 3. And I'm rising -4. So my slope is -4/3. Now hold on. The rule for perpendicular lines is opposite reciprocals. These are opposite reciprocals, meaning that AD and BC have to be perpendicular lines and they make a 90-degree angle. Now, we just not gonna go through that tonight because I'm ready to go home. But your other explanation is in the slopes of the perpendicular lines are opposite reciprocals. Now, I do not want you to be stressing at home talking about something. How am I going to remember that whole paragraph? You word it how you word it. Talk in your words. But as long as you're saying they have equal lengths and the opposite reciprocals, we good. The lines are perpendicular, we good. Okay? Then I find the perimeter of ABCD. I know that the length of my sides was 5. Perimeter is all the sides added together. So 5 plus 5 plus 5 plus 5 is what? 20. So that's the perimeter. And my explanation is that 5 plus 5 plus 5 plus 5 is 20. Okay? Area is what? Length times width, right? Area equals length times width. My length and width was 5. So area equals 5 times 5. So my area is 25. Okay? Now those two was not hard at all. Let's make sure we still recording because my watch did. It looked like it. Okay? Let's move on. Alright, no tricks about that one. The only thing you really need to remember is this part right here. Area and perimeter, we cool with that. Solve the systems of equations without graphing. That means you cannot use Desmos, guys. Okay? So solve the easiest one first. If you are not sure on solving systems of equations, it's time for you to go watch another video when you're done with this one, because I just recorded that systems of equations video. Alright? Your final answer should be a point. So your point is 2, -1. Do not get on that test and only write 2, -1. You have to show your work. You have to show your work for at least this piece right here. Because if you show your work for this, all you got to do is say I plugged in -1 and found X. You at least need to show how you found -1 or whatever variable you found first. Okay? So we had a worksheet. Let me find it. The note sheet. So a while back, we took notes on this paper right here. If you have this paper, Right here on the test is where it's time to pull it out. So my solutions, if it's one solution, I know that they'll have different slopes. If it's no solution, they'll have the same slope but different y-intercepts. If it's infinitely many, that means it has the same slope and same y-intercept. So those are the 3 ways I know which one is which. I have to pay attention to the slopes and the y-intercepts. Now for all of them, is the slope and y-intercept just laid out right there? No. However, I do know one of them. So if I know, look at this one, I know my slope is 3/4 and my y-intercept is 7. So let me solve the other one for y so I can see what's going on. So there's my new equations. So let me write it out. So once I solve this second equation, and I rearranged it so everything's on top of each other, but this is the same thing. -8 plus 3/4 is the same as 3/4 x minus 8. Same thing. When I line them up, what do I notice about the slopes? They're the same slope. What do I notice about the different y-intercepts? Well, what do I notice about the y-intercepts? They're different. That falls under no solution. Alright, let's do the next one. This bottom one, we gotta solve both of them. Let's be honest. Both of them have to be solved, so we're gonna solve both of them. Alright, so once I solve both of my equations, this is what I got. My slope for both of them, -2. My y-intercept for both of them, -5. So what does that mean? If it has the same slope, same y-intercept, infinitely many. Happily, this one's already solved for y for us. The slopes are different. We can just look at it and tell the slopes are different. The y-intercepts are different. So which one falls under that? If it's a different y-intercept, different slopes, it falls under one solution. See, this isn't hard, right? Let's go to the next one. Graph represents the solution to the system of inequalities. Could you graph this? Yes, but you don't have to do all of that. You don't have to do all of that at all. What I would do is look at the easiest one first. Whatever makes sense to you first, and then do the process of elimination so you can make your life easier. This one right here, I already see the slope and I already see the y-intercept. I know that this line should be crossing at 1 and -2/3 of a slope. So sadly, all of them are crossing at 1 and all of them have a negative slope, right? However, something's different. This one's shaded under, this one's shaded above, and we only talk about this dashed line right here for right now. This one's shaded above, this one's shaded below. That means I got some process of elimination I can do based on just my sign. Greater than tells me I should be shading where? Above or below? Above. So anything where the dashed line is shaded below is not one of my answers. That cancels out right there. My only options are B and C. Okay? So let's look at the other one. C. Both of them cross at the same point. Both of them cross at the same point. They have the same intercepts. But when we're talking about the blue now, it's either shaded above or below. Now my sign is this. Now hold on 1 second. Because if we just go off this sign, we're gonna pick the wrong one. You're gonna pick the wrong one, and I'm gonna show you why. So let's say I wanted to solve this, right? I want to solve it, and I want to be sure what my slope and y-intercept and all that is. So I'm gonna solve for y. Pause. What happens to my sign when I divide by a negative? The sign flips. This is a trick, guys. It's a trick. So my sign, what I should be looking for in my graph is for a graph that's shaded above, because once I solve and get the slope and y-intercept, my sign changes because I divided by a negative. Okay? So I'm looking at whatever one where the blue is shaded above, and that gives me B. Okay? So for this problem, it's not asking you to graph it on the test, it's asking you these 4 questions. What is the y-intercept? What is the slope? Is it a solid or a dashed line? And is it shaded above or below? What you need to do first is solve it. So once I solved this equation for y, that's what I did. Your y-intercept, my y-intercept is 4. Write it like a point, please. 4. What's my slope? -4/5. Will it be a dash or a solid line? That's based on this. Remember, the solids are the equal to's. If it's not an equal to, it's not solid, so it's dash. And will I have a shaded above or below? It's less, so below. That's it for that problem. Line M is represented by the equation y plus 2 equals 3/2 times 3x plus 4. Classify each equation as parallel to line M, perpendicular to line M, or neither. So you're simply asking yourself, is it parallel, perpendicular, or neither? How do I know? Parallel has the same slope. Perpendicular has opposite reciprocals. Neither. So the slope of this is 3/2. I know that because when I distribute, it's just gonna be 3/2. So my original slope, I'll write it right here, is 3/2. And I'm just gonna go to each one and see, is it same, opposite reciprocal, or neither? -3/2. That would be neither. If it's the opposite reciprocal, I need it to be -2/3. I'm trying to think of how to write that. So it's not -2/3, it's not 3/2, so it's neither. Okay? -2/3. Perpendicular. 2/3. Neither. 3/2. That's the same. Parallel. My slope right here, -4/6. This is a trick. Because -4/6 simplifies to -2/3. So it is what? Perpendicular. 3/2. Parallel. Wow. You would think that this is hard. But it's not. It's just, boy, y'all leaning like T.I. Okay. Bam. That's, bro, this is 12 points right here. Just this one little piece. And which system of equations is the last question? Oh. Which system of equations is equivalent to 4x plus y equals 6? Bro, we talk about equivalent equations again. Equivalent equations are equations that have the same solution. So let's look at each one. So 4x plus y equals 6. That checks out because that's the same thing as that. That's the same thing. X plus 3y equals 3. Now just hold on a second. Because you change this to a positive, you change the -3 to a positive, but you ain't never changed this to nothing. All you did was change this side. Because if we do something on one side, we got to do it on the other. All right, let's look at the next one. 8x plus 2y equals 12. So if I'm looking at my top equation, I can already tell you multiply this by 2. Okay, you multiply the whole thing by 2. All right, that works for me. That's cool. -2x minus 6y equals 3. Now just hold on. Because you changed something on the left side, but again, you did not change nothing on the right side. Can't be equivalent, so it can't be my answer. Look at the third. 12x plus 3y equals 18. Okay, so I can already tell you multiply the whole thing by 3, and you multiply both sides. That's cool with me. -x minus 3y equals 3. You ain't even touch it. That's cool with me too. Baby, if you already found the answer, what you looking again for? Don't work smarter, not harder. We found the answer. The answer is C. Now the next problem on the text will be to explain how these two equations are equivalent. We know C is equivalent because they multiplied the top equation by 3 on both sides, and they didn't touch the next equation. So, all right, and there it is. So they multiplied the top equation by 3, And then they kept the second equation the same. And so that's how they're equivalent. And guess what we just did? We made 100 on our test. And I get to go home. It's 5 o'clock, y'all. God, you can't never say, you can't never in your life ever say that Miss Davis don't love y'all. Cause it is 5 o'clock. Whew. I'm finna go home.
Do is gas me. How we end up in the backseat.